Hi, I'm Greg Feeler from somewhere in California. It's a long story. I'm going to talk today about visualizing sound and how it's very important to be able to see what you hear. In the video lectures, we learned about three properties of sound: propagation, amplitude, and frequency. And we learned about three ways to look at sound: an oscilloscope, a spectrum, and a spectrogram analysis. The oscilloscope shows time and frequency. The spectrum shows frequency and amplitude. And the spectrogram analysis tries to show all three: time, frequency, and amplitude. That beautiful music you've been hearing is something I recorded in GarageBand. I'm moving up to Logic, and I want to learn more about the tools in Logic for visualizing sound, because like I said before, it's very important to be able to see what we hear. In this piece, I really want to have the guitar and the flute sound like they're coming from different sides. And so I had panned the tracks to be right and left. I used the multimeter to look at the spectrum and to see the correlation. A quick word about correlation. A correlation of 1 means that the sound coming from the right and the left is exactly the same. A correlation of 0 means they are completely different. A correlation of -1 means that they are opposites and potentially cancel each other out. Oh, hey, what's this? Goniometer. I wonder what that does. I think I'll add meters to all my tracks and play with this a bit. All right, here goes. That's not what I expected. The guitar seems to be completely straight up and down, exactly in the middle. What if I tried a directional mixer instead of just panning? I wonder if I could see the difference. Okay, here we go. Wow, I do see the difference. And equally as important, I hear the difference. It's subtle, but that's really the point. In order to be sure, or at least a little more sure about sound, it's important to both see it and hear it.